Hey, Calc kids. I've had a couple of you guys send me um, your homework assignment for section 6.2, which is this area problem right here that I left a video for. Some of you guys have sent it, some of you guys haven't. If you haven't, try to get that in to me as soon as you can. What I'm going to do, instead of moving on to section 6.3, I'm just going to do some antiderivative practice, just because we kind of left off on section 6.1 and I didn't get to answer a whole lot of questions. So we're going to go through a couple examples, and then I'm going to have you guys for homework just do the top half, 6.1 and 6.2, that review sheet, the top half 1 through 7, okay? So basically this entire page will be filled in for you all except number 9, which we'll skip altogether. We won't do number 9. So your homework for this section is going to be, or for this video is going to be 1 through 7, and we're going to do some problems for this antiderivative practice that are going to kind of help you out with this, okay, just to kind of refresh your brain a little bit. So if you want to write these down on another sheet of paper, you sure can as we're going through this. You don't have these. I made these examples up. So it might be a good idea to write them down somewhere, but this will kind of help you with that homework assignment, okay? So I'm just going to start with number 1 here. We have the fourth root of x, and so what we're trying to find when we're doing antiderivative is basically what is an equation that the derivative of it is the fourth root of x, okay? So that's what we're trying to find here. The formula that you're going to need is 1 over n plus 1. X to the n plus 1 power, okay? So that's what we'll kind of keep going back to each time. All right, so on each one of these problems, what you're going to want to do is you're going to want to rewrite it so that it's kind of in the proper form so that we can take the antiderivative of it. So the fourth root of x, just like when we're taking the derivative, I want to write him as the 1/4 power, okay? So he will kind of look like this, and we use that notation, that integral symbol with a dx on the end of it, just to say, hey, we're just rewriting it. We haven't yet taken the antiderivative yet. We'll get to that point. Okay, let me zoom in here and see. There we go. He's a little less fuzzy. Okay, so now we're going to take the antiderivative, and what we want to do is use that formula, 1 over n plus 1, x to the n plus 1. So I want to do 1 over, my n is going to be 1/4. Okay, and I'm going to add 1 to that, x to the 1/4 plus 1, okay? You'll kind of find as we're going through here that this bottom part, whatever your bottom part of your fraction is, will always be the same exponent as what the 1/4, what this top part is, that 1/4 plus 1, okay? So now we just need to simplify. So we've taken the antiderivative, but it's really ugly, and we're going to simplify it a little bit. So 1/4 plus 1, think of this as like 1/4 plus 4 over 4, which is going to be 5 over 4. Okay, so this whole bottom part right here would be 5 over 4. Now if I have 1 divided by 5/4, that's just going to be like a keep flip flip, which will become 4/5. Okay, that's what he will look like if I flip him around. And then I will have x to the 1/4 plus 1 again, which we said here was 5/4. Okay, and that will give me my antiderivative, except I need to put that plus c on the end there, okay, because we're saying the derivative of this guy will be the fourth root of x, and that c will drop off if I take the derivative, okay? If you kind of take the derivative in your head here, if I want to check to make sure that that's the fourth root of x, I would drop the 5/4 down in front, okay? You don't have to rewrite this. But drop the 5/4 down in front. 5/4 times 4/5 is going to cross those out, and that's going to become 1 x to the, if I subtract 1 from 5/4, that would be 1/4 power, and then the c is gone. So x to the 1/4 power is the square root of, or is the fourth root of x, and it checks out. Okay, so my antiderivative is this guy. Taking the derivative again, just to check my work, is what we did just then. Okay, all right. Number 2 is going to be a little bit easier of an example, just because we don't have to deal with like negative exponents and yucky stuff like that, okay? So 5x to the 4th power, okay? I'll I want to treat each one of these pieces individually. So I'm just going to do them one by one. 5x to the 4th power. What I'm going to do is the only thing that's going to change here, because that 5 is there, is rather than the 1 up here at the top, 1 over n plus 1, it's going to be 5 over n plus 1. Or really kind of like 5 times 1 over n plus 1. So I usually just drag that 5 to the top. So 5 over n plus 1. Okay, and n is going to be that 4th power. So 4 plus 1, x to the 4 plus 1. That's what he will look like. Okay, so that's the only thing that 5 does, is it's like 5 times 1 over that, or just 5 over 4 plus 1. Okay, and what that guy is going to become, 5 over 4 plus 1. This is like 5 over 5, or just 1, x to the 5th power. Okay, if you think about taking the derivative of that real quick, 1x to the 5th power, if I drop the 5 down, that would be 5x to the 4th power, just like what I have up here. Okay, all right, now let's move on to 6x squared. Okay, so 6x squared would be 6 over n plus 1, or 2 plus 1, x to the 2 plus 1, right? 6 over 2 plus 1 is 6 over 3, which will just be 2x to the 3rd power, okay? And then it's minus, so I need to put a minus sign in between them, okay? Now think about taking the derivative of negative 2x to the 3rd. I bring the 3 down in front. That becomes 6x squared, and that's what I have, okay? Now this next one, 7, I just think about, okay, if I'm taking the derivative of something, that derivative is 7. What would it have to be to start with? It would have to have a 7x on it. The derivative of 7x is just 7. And then I need plus c, and that's my final antiderivative. Okay? All right, so a little bit of scratch work in between there, and then you simplify, and it comes out kind of nice on that one. All right, now this next one, you're going to have to rewrite him a little bit before you can do anything here. All right, so blah, blah, blah. Come on here. There we go. Okay, so what I'm going to do is this top part. Okay, I'm gonna leave him the same, except that square root of x. I'm going to make him to the 1/2 power. So I'm going to write him as x squared plus x to the 1/2 power plus 1, like that. Okay, so just kept the top kind of the same, except that middle term I'm going to change him to x to the 1/2 power. And then this x squared, if I were to move him to the top, he would be like x to the negative 2 power. Okay, and so I have this going on here, and I'm going to rewrite him one more time after I distribute this x to the negative 2 power through. Okay, that's what I'm going to do. I'm going to do that. All right, so if I take x squared and x to the negative 2 power, okay, you're going to be adding the exponents to each other. Adding the exponents. So 2 and a negative 2 will actually be x to the 0 power, which is just 1. Okay, that's what he will end up looking like. All right. Now the next one, x to the 1/2 power and x to the negative 2. Okay, I have a lot of people who think that's just negative 1 because 1/2 times negative 2 is 1, or negative 1. But you're adding the exponents. So it would be like 1/2 minus 2. Okay. 1/2 minus 2 is a negative 1/2, or a negative 3/2 power is what he would look like. Okay, so that's kind of ugly business, I guess, a little bit. And then 1 times x to the negative 2 power would be just x to the negative 2 power. Okay, so now he is ready to take the antiderivative. Oh, yeah, how ugly is that? Okay. All right, this first term, if I take the antiderivative of 1, it's like, okay, what would my original equation have to be in order for the derivative to be 1? And that's just going to be 1x. Okay, the next piece, I'm going to do kind of some scratch work up here. X to the negative 3/2. Okay, I would do 1 over negative 3/2 plus 1, x to the negative 3/2 plus 1. That's my formula. All right, and then we just have to do some work simplifying. Okay, negative 3/2 plus 1. This would be like negative 3/2 plus 2/2 would be a negative 1/2 on the bottom. Okay, But 1 divided by negative 1/2 is going to be negative 2x to the negative 1/2. Okay, so that's what he will look like down here as my next term. Negative 2x to the negative 1/2. That's what he will be. Okay, and then the last one that I have to do is x to the negative 2 power. I'm going to do scratch work over here. Okay, 1 over negative 2 plus 1, x to the negative 2 plus 1. Okay, so negative 2 plus 1 is going to be negative 1, and 1 divided by negative 1 is just going to be negative 1 x to the negative 1 power. Okay, minus 1 x to the negative 1 power, and then I of course need plus c. Okay, the only other thing I'm going to do to change this is 1x, or you can just leave him as x, he doesn't need the 1 in front, minus, this would be x to the 1/2 power on the bottom. Okay, and 1/2 power means the square root, so this is what he would look like. Okay, 2 over the square root of x. Okay, minus 1 over x, if I move that x to the bottom, plus c. That's him kind of fixed so that his he doesn't have any negative exponents. So that kind of makes him a little bit nicer looking, I guess. Okay, and then again, you can go through and you can figure out what the derivative of this is if you want to check your answer to make sure that you did the antiderivative right. I would always encourage you to do that. Okay, all right. Number 4. This one I put in here because it's really similar to one that you have in your homework assignment, and I know it's going to kind of throw people for a loop because you're going to think that you need to move the 5 to the top along with the x squared, but you do not. So when we rewrite this guy, we're going to move the x squared to the top, but we're going to leave the 5 on the bottom. So this is just going to be 3/5 x to the negative 2 power. Kind of if I move that x to the top, that's what he will look like. Okay. Then from there, this one's kind of fairly easy. All I need to do is I need to do 1 over n plus 1, x to the n plus 1, and in this case, my n is negative 2. Okay, so for this, because this 3/5 is really kind of ugly, I'm gonna just shove him off to the side. Up above here, when we had that 5 out in front, I just did the 5 on the top. I'm going to hold off on the 3/5, and I'm just going to wait and multiply him through at the very end. So I have 3/5 times 1 over n plus 1 will be negative 2 plus 1, x to the negative 2 plus 1 is what he will look like. Okay, and negative 2 plus 1 is going to be negative 1. I think we just kind of did this problem, didn't we? Yeah, right here. We were finding the derivative of x to the negative 2. Okay, whatever. X to the negative 2 plus 1 is going to be x to the negative 1 power. Okay, so basically I have 3/5 times 1 over negative 1, which is just going to be negative 3/5 x to the negative 1 power, which actually is negative 3 over 5 x to the positive 1 power. And then I need my plus c on the end. Okay, and that's what he's going to look like. Okay, so you could do the derivative of this to check to make sure. If I did the derivative of this guy right here, I would multiply the negative 1 down in front, which would make that positive 3/5 x to the negative 2 power, positive 3/5 x to the negative 2 power. That's what I started with, so we're good to go. Okay, that's what number 4 looks like. And then last one, number 5, find the exact equation for y, which goes through the point 17, given that the derivative is 6x plus 4. So they give me the derivative equation. They want me to find what actually y is, and then they want me to go through the point 17. So it's going to involve taking the antiderivative. So let's worry about that first. So we have this guy, and we want to find the antiderivative of him. Okay, if we write that out in notation, that means we're looking for the integral of 6x plus 4, okay, dx, and we need to figure out what that is to start with. Okay, so just dealing with the 6 to start with, 6x. Okay, I'm going to do 6 over n plus 1. Okay, in this case, n is my exponent, which is just 1, so I have 1 plus 1, x to the 1 plus 1 power. Okay, you guys might be doing these in your head at this point. I keep writing everything out, but you might be able to do these in your head at this point, which is fine. 6 over 2, x to the second power, so that's 3x squared. Okay, 3x squared. If I take the derivative of that to check my answer, will be 6x to the first power. That's right. Okay, and then the last piece, 4. I'm trying to take the antiderivative of 4. So what would the original equation have been? In order to get the derivative to be 4, it would have to have been 4x, and then I have plus c. Okay, now I'm not quite done yet because they want the exact equation. Okay, this one has a plus c, and I have no idea what c is other than that c is just a number. And so I have y equals this whole big long thing, but I want to know what c is exactly. So what I can do is I can plug 1 in for each one of these pieces, and 1 in for each one of the x's, 7 in for the y, and see what we get to come out as an answer. Okay, I think I made this come out too nicely. So y is going to be 7, x is going to be 1. Okay, so 3 times 1 squared is just going to be 3, plus 4 times 1 is 4, plus c equals 7. Yeah, I did make this come out really nice, or too nice, I guess. 3 plus 4 is 7, so I have 7 equals 7 plus c, in which case c would have to be 0. Okay, so my exact equation is y equals 3x squared plus 4x plus 0, or just 3x squared plus 4x. That's what the exact equation that goes through the 0.17 is. Okay, so there is how that kind of boils down. So this is just some practice just to kind of get us back into finding the antiderivative before I move on to 6.3. This is just really going to help. So what I want you to do is go ahead and work through problems 1 through 7. See how you do with those. Again, email me if you have questions. You know, I can video conference with any of you if you have questions, even if it's just you that wants to do it. 7, go ahead and send those to me through Google Classroom or email, whichever one you prefer, it doesn't matter. And then we'll start section 6.3 in the next video. Okay?